guys, in this video we're going to run through a quick little introduction as to what inequalities are, and we're also going to take a peek at putting them on number lines. So yeah, it's going to be quite an easy one. You're not going to have to put up with any of my terrible handwriting, so let's get cracking. So first of all then, what is an inequality? Well, we've probably been playing with equations for much longer than inequalities. Remember that an equation tells us an exact value for our variable, for our letter. So for example, if we've got an equation like x equals 2, that tells us x is equal to and is only equal to 2. Whereas if we had this inequality down at the bottom where we've got x with this little pointy arrow and then a 2, we would read that as x is greater than 2. Now technically that means that x would be allowed to be any number greater than 2, say like 2.1 or 2.0000001, but when we're playing with inequalities we are usually just playing with integer values. So, there are different types of inequality. The tip of the arrow is always pointing at the smaller part of the inequality. So the small part of the inequality is pointing at the small component of the inequality. So this top one then we would read as x is strictly less than 3. So in integer terms then x would equal 2, 1, 0. Every single number down to minus infinity x is allowed to be. The next one down we would read as x is strictly greater than 3. So 4, 5, 6 and every number up to positive infinity. And then we get these two down the bottom where we've got a little line underneath the inequality. It's a very subtle difference in notation, but it does mean something quite different in terms of the inequality. So this first guy then, we read that as x is less than or equal to 3. So x here is allowed to equal 3. With the inequalities above, x was not allowed to equal 3. So x is less than or equal to 3 then. X is allowed to be 3, 2, 1, 0, and again any number down to minus infinity. And then we got the second guy, x is greater than or equal to 3. So x is allowed to be 3, 4, 5, all the way up to positive infinity. So we also can come across double inequalities where our variable is bounded from below and above. So this top chap here, x is greater than 0 strictly, but x is strictly less than 10. So here the integer values that x could take would be 1, 2, 3, 4, 5, 6, 7, 8 and 9. It's not allowed to equal 0 or 10. So inequalities sort of work like bouncers. They're not letting x go below and they're not letting x go above. So this second chap here, x is greater than or equal to minus 2 and it's less than or equal to 3. So the integer values here that x could take would be minus 2, minus 1, 0, 1, 2 and 3. So that's the difference that these or equal to inequalities make. X is allowed to equal the numbers at the bounds. Again though, it's still not allowed to equal numbers lower than the lower bound or numbers higher than the upper bound. Okay, so here we've got a mix. X is greater than or equal to 1, but strictly less than 9. So here the integer values that x could take would be 1, 2, 3, 4, 5, 6, 7 and 8. It is not allowed to equal 9. And then the second one on the page, x is strictly greater than minus 5, but is less than or equal to 0. So the integer values x could be here would be minus 4, minus 3, minus 2, minus 1 and 0. Okay, so That's our introduction to inequality notation. Now we're going to have a look at representing them on number lines. So we need a little bit of notation knowledge first of all. We use a hollow dot to represent strict inequalities, and we use a filled in dot to represent the or equal to inequalities. So the best way to explain this is by using examples. So represent x is strictly greater than 2 on a number line. So we put a hollow dot above 2, and then x is allowed to be everything greater than 2, so that's going off to positive infinity. So we stick a little arrow on going off to the right, off of our dot. Represent x is strictly less than 5 on a number line. So again, we've got a strict inequality, so we put a hollow dot on, and we put it above 5. That's the bound of our inequality. This time x is everything less than 5, so we stick an arrow going down to the left into the negative, off to negative infinity. So represent x is greater than or equal to 0 on a number line. So this time's a bit different. He's allowed to equal 0. So this time we use a filled in dot, and it's everything greater than or equal to 0. So we stick an arrow going off to the right, off to positive infinity. Okay, we can also represent the double inequalities on number lines. So represent x is greater than -1 strictly, and strictly less than 4. So here we've got two strict inequalities. So we're going to use two hollow dots, one above each of the bounds. So we stick a hollow dot above -1, and we stick a hollow dot above 4. This time we don't use arrows, we just connect the two dots with a straight line. So that's how we represent the inequality. X is strictly greater than -1, but strictly less than 4. Represent x is greater than or equal to 3, but less than or equal to 5 on a number line. So this time x is allowed to equal both of his bounds. So we stick a filled dot above 3 and above 5, and then again we just join them up with a line. Represent x is greater than or equal to 2, but strictly less than 7. So here then we've got a mix. He's allowed to equal one of his bounds, but he's not allowed to equal the other. So it's allowed to equal 2, so we shove a filled in dot above 2, but he's not allowed to equal 7, so we put a hollow dot above 7. And then again, we just connect them with a straight line. Job's a good one. Okay, and then the final example in this video. X is strictly greater than 1, but less than or equal to 9. So again, it's allowed to equal one of its bounds, but not the other. So we stick a hollow dot above 1, because he's not allowed to equal 1, and we stick a filled in dot above 9, because he is allowed to equal 9, and then we join the two dots with a straight line. Job's a good one, guys. Hope that served as a nice introduction. Be sure to check out the rest of the videos on inequalities. Was this video helpful? If so, be sure to leave a thumbs up and a comment telling me how you get on. For any further information, you can follow me on Facebook and Twitter, and send requests or any feedback you have. Search for Maths with Mouth. Cheers, guys.